Hello students, this is the third part of series of mathematical expectation. In this particular video, I will be discussing how to find expectation of a joint probability function. So here one question I have discussed. In this question, x and y are two random variables. It is provided g of x comma y is x into y. It is given in the question, and our aim is to find expectation of this gxy. It means, what is our aim? Our aim is to find expectation of x into y. One table is also provided in this question, and which is representing the values of fxy. This fxy is representing joint probability mass function. If we will see here, x is having three values 0, 1 and 2, countable number of values. Y is also having three values 0, 1 and 2, countable number of values. And for these values of x and y, some functional values are already given, like 3 by 28, 9 by 28, 3 by 28, 3 by 14. It is also 3 by 14, 0, 1 by 28, 0 and 0. If we will sum up the entries in this row, that is 15 by 28, sum up the entries in second row, that is this, sum up the entries in third row, this is 1 by 28. If we will sum up the values in first column, that is 5 by 14, sum up the values in second column, 15 by 28. If we will sum up the values in third column, that is 3 by 28. And this total probability is 1. If I will compare these values in this form, we can understand this is f00, x is 0, y is 0. So this is f00. This second value is f10, f20, f01, f11, f21, f21, f02, f12, f22. Now thereafter we can discuss here how to move ahead in this question. Since discrete data set is provided here, x is having three values, y is also having three values. There is a formula for expectation of a joint function, that is expectation of gxy is summation x summation y. This gxy is converted into g small xy into fxy, where this fxy is known as joint probability mass function. So we can put the values here of x and y. X is running, it means x is taking the values from 0 to 2. Y is also taking the values from 0 to 2 of gxy, fxy. What is gxy in this question? That is given already in the content of question. Gxy is x into y, so I am replacing it. I have replaced here gxy is x into y. So this xy will be now small xy into associated joint probability mass function. Now there might exist different ways to solve these summations, but I have taken it like this. Summation x is 0 to 2 of x, and then inside the bracket I can write here summation y is 0 to 2 y f of xy, because I have to apply this summation y over the terms of y. So how I can expand this particular term? So first I will be utilizing y equal to 0. So it is 0 into fx0, y equal to 1 is 1 into fx1, y equal to 2 is 2 into fx2. 0 into fx0 is not making any sense. It is 0 ultimately. So I can remove this term. So only this term and this term I have written along with x. So x multiplied with this term and x multiplied with this term here. So only two terms along with the summation. Now this summation is distributive in each and every term. So I can apply this summation over this term and I can apply this summation over this term. So that is what I have written here. It is just like summation x is 0 to 2 x into fx1 plus 2 summation x is 0 to 2 x into fx2. Now for this particular summation I will be first applying 0, 1 and 2. So it is 0 into f01, 1 into f11, here 2 into f21. So this is all about the first bracket. In this one, when I will expand this summation multiplied with 2, 2 into x is 0 into f02, that is what I have written, 1 into f12, 2 into f22, 2 into f22. This is what I have written. So as we know, few terms again will be removed here. 0 into f01 is 0, so no problem. 0 into f02 is also 0, so we can remove it. So what terms we are left with here? This, 2 into this term and 2 into this term. 4 terms we are left with. So I mean to say f11 plus 2 into f21 plus 2 into f12 plus 2 into f22. Now the question is like this: how we are going to get these values in this particular expression? So these values are already provided in the question. If I am talking about these three values, f21, f12 and f22, all these values are 0 in the question, and if 1 comma 1 is given as 3 by 14. So we will check it in the given table. As we can see, f21, f12, f22, all these are 0, and this is f11, that is 3 by 14. So that is what we can utilize here. So as I discussed here, this value is 0, this value is 0, this value is 0, and this value is just 3 by 14. So ultimately our final answer is 3 by 14. I mean to say this particular expectation of x into y is 3 by 14. So this is all about this first question. Now similarly, the second question, in this second question, one joint probability density function is given, joint PDF is given. It means continuous data set is provided, x is 0 to 2, y is 0 to 1, and for this range fxy is given like this. If the variables are outside of this range, then its value is 0. So what is our aim here? Our aim is here to find expectation of y by x, expectation of y divided by x. This is our aim here. So what we can do here, we can apply this formula. Formula here is expectation of gxy, since it is continuous data set, so summation will be integration 2 times, because 2 variables are given, minus infinite to infinite, minus infinite to infinite. This will be g of xy into associated, it is students joint probability density function. Gxy is taken as y by x because of the question. So y by x, it is replaced here, and this y by x will be small y by x into associated fxy. Fxy means joint PDF. Now fxy is already given in the question, that is x by 4 1 plus 3y square. So x and x will be cancelled out. So we will be having here 1 by 4 double integration of y into 1 plus 3y square dx dy. Now here inner limit is for x, so I am going to solve for this variable x first. So inside the bracket I have set the preference here. For x, limit of x is given in the question from 0 to 2 and limit of y is from 0 to 1. So I have set the limit of x here 0 to 2 and thereafter limit of y is from 0 to 1. In the concept of double integration, we know if we are dealing with x variable integration for integration sign, then y is treated as constant. If y is treated as constant inside this particular bracket, so I can take this whole term of y outside the integration, this particular integration for x. So that is what I have done here, y 1 plus 3y square, and inside the bracket we are left with 0 to 2 dx. So when we will be solving this single integration, it will be 2 minus 0. 2 minus 0 means it is just 2, and this 2 by 4 is 1 by 2, and only single integration will be there. And solving the single integration is not a big deal. We can easily solve this single integration. So that is what I have done here. I have applied upper limit and minus lower limit. It will be just 1 by 2 into 5 by 4. Ultimately it is 5 by 8. So expectation of y by x is 5 by 8. So students, in this particular video I have discussed one question from the topic of expectation of joint function in discrete data set, and one question I have discussed of expectation of joint function in continuous data set. Thanks for watching this video.